So let's go ahead and get started. Today we're going to, we're going to go through your last two quizzes, which hopefully solidify a little more about object-oriented programming. And then we're going to start going into the next section, which talks about basically composing objects of objects and how to model objects to real-world applications. One thing about object-oriented programming, if I haven't talked about this yet, is that there's a lot of chicken and the egg problem where a lot of it doesn't make sense until you see the entire picture. So if you're a little clueless right now, or you're having some difficulty understanding why we're doing things a certain way, just stick with it. It should gel together in at least probably in the next 2 or 3 weeks what's actually going on. Also, how's everyone feeling? I've been told everyone stayed up late last night.
Yeah.
Is everyone in here in applied networking as well?
No.
No, y'all are not?
Already took it.
Already took it? Okay, so, but most people probably are. Okay. All right, well, fortunately that's how it goes. All right, let's get on to it. Morning. So what would be a statement that prints the value of a string object called title in all uppercase letters? Take a guess. All right, 2 uppercase. Yeah, but what would be the entire command or code?
System.out.
System.out.println line. Yep, parentheses.
The quotation marks.
Well, hold on.
Title.
No, it's a string object called title. So then, yeah, title dot 2 uppercase. Okay. So this is really an exercise to go look up what function to call out there, and it's a good exercise because you need to learn. Google's your friend. How do you find these functions to call? Don't be afraid to do that. So what package contains the scanner class, the string class, the random class, and the math class? Ooh, here we go. Scanner class. Huh?
Scanner.
Yeah, what's scanner in?
Lang.
Lang? No, it's not lang. Java.util. So what would string be in? Lang. Java.lang. Random. What is random in? String. Math is in java.lang. And I totally ignored the random class. Did we talk about what's special about the java.lang package?
I don't think so.
I think so. What's special about, what is special about the java.lang package? It is automatically included in all your Java programs. You don't need to import it. It's automatically imported. So given a random object called ran, so it's an actual object of the class random, not just some random object out there. It's actually of the class random, called ran. What do you think ran.nextIn passing in 30 returns?
In the 30 position.
It does what?
Next int in the 30 position.
Next int in the 30th position?
Next, the 30th next.
The 30th next?
The 30th next.
No.
The next 30.
The next. Keep on guessing.
Yeah.
Accuracy by volume, right?
60.
60.
Just double it.
Okay, it's going to return an integer. What's going to be the range of that integer?
30.
Not 1 to 30. Close. 0 to 29. There we go. Again, Google's your friend. Look it up. How about...
When we take these on Blackboard, will it give us the correct answer at the end?
No.
No?
But the PDFs are on GitHub that tell you the answers.
Okay.
But you should do the ones on Blackboard because that's how your midterm and final are going to be set up. Gives you practice. But this is just easier during class. Slide format. All right. So you come with a declaration for a double variable called result and initialize it to 5 raised to the power of 2.5.
Double.
Double.
Result.
Result. Good.
Semicolon.
Okay.
Yeah.
Yeah, you can do it that way. Sure. Semicolon, then.
Result equals pow or yeah, pow 5.
Not pow. Remember, functions have to be remembered.
Math dot.
Yeah, there you go. Math.pow. Passing in.
5.
Yep. There we go. Oh wait, any questions on this one? Double result. We're going to have a variable called result. Its type is double. We're going to set it equal to, we're going to call the function pal, which is a member of the class math, passing in 5 and 2.5. And whatever that returns, we'll stuff that's result inside of result. All right. Oh, so no one's going to know this off the top of their head. Or the steps to output a floating point value as a percent using Java's formatting classes.
Great. I don't know that.
Yeah, no one's going to know this. That's fine. The quiz is really an exercise of looking it up and figuring it out.
System not out, that's right.
System. So you initialize a float fval. So we're creating an identifier called fval that is of type float, and we're going to set its initial value to 3.14159. Then we're going to create a variable called percent that's going to point to a number format object. Let me put my mouse pointer so as I read this. We'll create a variable percent that's going to point to a number format object, and we're going to get a number format object using number format.get percent instance. This is a different way than using new. Certain libraries allow you to do it this way. So now this is going to return a pointer to an object, and we're going to store that pointer in percent. Then we're going to go to the system.out class called the print line, passing in percent, which is that object, dot format. So we're going to call the format function of the percent object, passing in fval, and then I'll return it as a percent. Percent. There we go. Any questions on that? Over last class, I did do memory with static, stack, and heap. Is that correct? Good. Just double checking. I'm going to try and remind me to keep going through the steps of everything that's happening so that gets solidified in your brains. Okay, here we go. What is the output of the following code fragment?
It's a thing. Replace.
It's a thing?
It's a thing.
It's a thing.
This is
The Holy Grail.
Well, hold on. Quest for, that's correct.
Zoli Grail. Zoli Grail.
Not Zoli. Well, what about THE?
Oh. this is
TZE, because we're calling the replace on the entire
Z.
M3. So it's quest for TZE space, and then is it holy or Zoli?
No, it's because it's capital H.
It's
not.
capital H, so it's still holy Grail. And then what comes next?
Where's the Holy Grail?
Quest for, and then it's TZE, the Holy Grail. Let me see if I typed that all out incorrectly. Okay, so this needs to be a Z as well. But yeah, Z, quest for a Z, all Zoli. There you go.
Take out the T. Quest for the Z.
Yeah, that should be a
Why
Z.
is that H still in?
Because it's a capital H.
Quest for the Z.
What about the? that's
Right,
the-
this one should be a Z,
Oh, okay.
just like that one. That's a mistake on the board. Again, this should be a Z. But that's not changed because it's capital H and we're only affecting the lowercase h. Any questions? Okay, great. Let's do your other quiz. All right. Ooh. How do you determine what's public and private? When you're considering your class, and you should always take a moment to evaluate how your class should be set up before you write it,
Actually,
as should everyone. What should be public and what should be private?
Public is what you want shared across multiple classes, while private should only be used in one specific class.
In your class, right. So how do you determine what should be private and what should be public?
If it's only going to be used in one class, it should be private.
Okay, yeah, if you expect the users to only use, if you expect none of the users to have to use it, it should be private, but your public should be only what's presented to other users,
Yeah.
other programmers. There are different ways to put it, but one way to think about it is, in general, everything should be private except what needs to be presented to the user. So by default, make things private unless you need to present something to the user. And of course you need to, so you need to have something public. But think of it from a perspective of keeping as much private as possible. So what's object persistence? No amusing comment, Tyler? You're writing code. Awesome. So did y'all ever do new inside of C++? No. So if you remember up there when I was talking about the heap, and you created something new on the heap, what was its lifetime?
I think it was until you deleted it.
Until it got deleted at some point. In Java, you don't delete. It takes care of that eventually for you. So the point is, in C++, you have functions, and your lifetime is essentially the scope of that variable, and once it goes out of scope, it's gone. But now you have a heap, so your object is allocated on the heap, and it can persist there until at some point later, maybe when you've lost all your connections to it, it'll be deallocated. So it's a little more persistent. Objects are a little more persistent in Java than in C++. Technically, it's an object's ability to retain state. Namely, an object's persistent if it stays alive after going out of scope. So you may no longer use it in your function, but maybe later you'll use it again at some other state, at some other time. But the state of that object hasn't changed. It's remained persistent. So when designing a class, the general rule is to always provide the user with as little knowledge of the inner workings of the class as possible. Why would we do this? So people don't copy your work? So people don't copy your work. They have access to your source code.
Because they don't need to know all that.
They don't need to know all that.
They won't understand.
Well, hold on. They don't understand, right? And so why would that be helpful if they don't need to know all that?
So it's like that example with the toaster. They don't need to know how the toaster works. They just need to
Know how to use it.
Yeah, how to use it.
Right. So in order, if you're trying to make toast, you don't need to understand the inner workings of a toaster. You just put toast in, hit button, right? So it helps simplifies other people's work. They don't have to worry about the inner workings of your toaster. They just need to know how to use your class. I wonder what was written up here. Wow, I definitely prefer your toaster model a lot better. That was a far better answer than what the book gave. Whew. Okay, we're going to skip that. Write the toaster example down if I ever ask that. Oh, man. All right, please.
That's what a best on test.
Toaster. Toaster.
Would you accept that?
Give me a little more than that, all right? All right, give me a little more than that. Okay, next one. Please describe 3 different types of interfaces. Ooh. There are a lot of interfaces out there. There's a user interface to what? Okay, so what would that be? In code. So okay, a user interface. So that might be mouse, keyboard, monitor. Right. There's your interface. You type keys on the keyboard. You move things with the mouse. You get feedback from the monitor. All right, that's one user interface or one interface. Interface does not have to be about computers. It can be something else. What could be a different interface? You use these all the time. We haven't labeled them yet. What did we just talk about?
Toaster?
Toaster. So there's an interface to the toaster. Put bread in, push button. That's an interface. The wall socket's an interface as well. They're all interfaces. They're just how you connect to something. Do you understand? I'm getting a lot of blank looks, and I don't know if that's the, oh, okay, fine, or the, I have no idea what you're talking about. Okay, guys, I know it's tired. I know you had a long class last night.
So interface is basically anything you interact with or connect with, I guess?
It's how you do it.
How you do it.
Yeah, it's the accepted practice. Your toaster has a lever, and you put toasting on top. That's the interface. You don't care what's underneath the interface. You just, how do you actually interact with something?
So even a whiteboard could be an interface.
Right, because I'll have markers and an eraser, right?
Yeah.
Yeah. So that's the interface. You don't care about how the marker's ink stays on the board or how the eraser erases it. You just know that that's how you use it. So it's how it's being used. So yeah, computer, keyboard, mouse, monitor, that's an interface. Toaster, wall socket, the 3 prongs in a certain position, you get 110 volts, 120 volts, depending on what it is, up to a certain amperage on 2 prongs and a ground wire. Again, that's an interface. You don't care how they got you the power or the fact that it's carried over wires. You just know how to interface with it. So let's see, command line interface, keyboard. Your object interface as well, aka your public methods to your object, is the interface to your object. So when we talk about object or interface in this class, most of the time we're talking about the object interface inside of your class, aka your public methods. Okay, any questions on those? All right, last class, I did ask for people to email me a couple of more ideas. I think got one back for a finance tracking application, which I think would be pretty cool. But here's the whole list. Excuse me. Right now, game, text-based, blackjack, chess, or you can try and do Super Smash Brothers. You'll probably want to simplify that a lot. Mario, asteroids, some type of jumping game. Apps, we got body fat calculator, nutrition tracker, a daily fitness reminder. A lot of new fitness stuff right now. That's great. And then finance budgeting or finance tracking. And then a car, hotel, rental reservation system. All right, guys. So take a moment right now. Look at these. Do you have any questions about what's up on here, or do you have any other suggestions to add? Yes. Pac-Man? All right, so I'll make sure I add Pac-Man.
Kings in the corner.
Kings in the corner. What? I haven't heard of that in a
No
long
one
time.
puts king in the corner.
All right, so we
It's
got
just solitaire before more than one person.
That sounds terrible.
Whoa.
That sounds terrible.
So Kings in the corner. So remind people how that one works, because I can't remember off the top of my head.
Alright, so it's really hard to explain it without an actual deck of cards.
Oh, okay.
Because, alright, so you've got 4 players. Normally it's 4 players.
Mm-hmm.
8 if you're doing teams of 2.
Sure.
And that would require more than 1 deck of card.
Sure, that's fine.
Alright, so
Computer doesn't care about number of
yeah,
cards.
you have 4 corners. You obviously place the kings there. You would start the solitaire stack going downwards with the start on the kings.
Okay.
But instead of it being opposite color, fluctuating colors, it's all one suit. But in the middle, you have the deck along with 4 other cards. And those 4 cards, they also go down in ascending order, but that's in alternating colors.
So what's the objective?
Try to get rid of all your cards first.
Okay. All right. So I'm going to write this as card game.
Yeah.
And I mean, I'll put kings in the corner, but you could probably do solitaire or war or whatever else. Yes.
Could we build up checkers up there too?
Sure. Checkers. I just realized I'm writing up on the board, but that's just a note to myself. Online people, feel free to put up checkers, Pac-Man, Kings in the Corner, a card game, or just any type of card game as well. All right, any other comments? Questions?
Could we just tell you during, after class, because I can't figure out my password.
Yes, I'll remind me after class to send email to everyone requesting with the full list and requesting it again. But remind me of that so I don't forget, because I forgot to do that last time. Any other comments? Other suggestions? Okay, we got to get this kicked off. Oh wait, comments? Okay, we got to get this kicked off because I really want to try and help you do this correctly. So I want to make sure we start off the beginning by actually doing all the parts that need to happen to make a project work in a group. So you need to email me your top 3 choices by January 26th. Yeah, January 26th. That's actually January 25th. I take that back. I need them by the end of tomorrow. Your top 3 choices. So I will update that and send that out as well. Remind me. I'll get to that. All right. Okay. There. Mental note. Or note. I need to then assign groups ASAP, and then I can give you what your first part of the project will be, which is basically setting down the requirements and describing what your project is. So it's not going to be too complicated, but you do need to sit down and decide on what's happening. Now, email me your top 3. I try and give everyone their first choice. I will tell you in general that not everyone gets their first choice, but usually you get your first or second. I think only a handful of students I've had to go down to their third choice. So in general, you will get your first or second. I will assign teams. There are a couple of requirements for the teams. Usually I like to put 1 graphics designer and 1 online student per team, but that may not happen this time because I think we only have 1 graphics designer in class. Is that true? Just, you're the only one? Okay. But there are online students, and it's very important you learn how to deal with online students because that's where everything's going. I've had to work with people who work online pretty much the whole time as well. It's they can still be very productive, but you have to know how to manage them. And I'll give you far more instruction about that next class. So any questions about the project ideas or what I mean by your top 3? Hopefully that's straightforward. Nope? All right. Before I forget, make sure you read chapter 4 of your object-oriented thought process, and that should be a new line between the forward and core. And then read the first section of chapter 3 on core Java, and we'll start talking about interfaces as well, and we'll get to that next class. Okay. Let me go ahead and stop.